In this video, we are going to see how the KMP algorithm works, which is a string matching algorithm. So we are given this text and we are given this pattern, and we need to find whether this pattern exists in the given text or not. So the first thing that we need to do is we need to create an LPS array, which is the longest prefix suffix array of the pattern. So we have this pattern, and what we are going to do now is we are going to assign numbers to the repetitive characters that we get in the pattern. So in this case, if you see the first letter A, which has never been seen before, so it would be 0, but then for the next A we can see that it has been repeated, so it's 1. So now we have a pattern called as AA, right? After that we see B, which is for the first time, so that's a 0. Then we see A again. Now this A is different from the previous A since the pattern does not repeat, so it would be 1. Then D and C is 0. This is how we create an LPS array. Let's look at some other examples so you can understand how LPS arrays are created. Let's see on the right. So we have this example where we have ABA, BACA. In this, we need to assign the LPS. We have to fill the array. So 0 0, since A and B is the first time we are seeing them. Then 1, then 2. This 1 and 2 means that we have found A and B previously also, and this particular pattern has been repeating. That's why it's 2. When we go back, we put 3 over here, since we already have ABA as pattern, so ABA becomes one pattern which is repeating. Then we have C. So when we go to C, the pattern has been broken, so it's 0, and then A is again 1. So we start the numbering again. If we go to example 2, we have, well, let's say we have all the letters as AA, so it becomes 0 1 2 3. For example 3, we have ABC, AB, AY, ABY. So first time, so all 0, but then AB repeats, which we have seen already over here, so it becomes 1 and 2, and then Y is new again, so that would be 0. So that's how you create LPS arrays. Now let's start understanding the algorithm. So we need two arrays over here, okay? One array, we need two pointers here. So we take 2 pointers. One would be I, and the other would be J. J goes for the pattern and I goes for the text. What we are going to do is we are going to take help of the LPS array to reset the J pointer if there's a mismatch. Okay, so let's try to iterate. So we check I and J. We see A and A matches. We do I plus plus, and we do J plus plus, right? It comes here. Then we keep on matching till we find a mismatch. Now when we come at this position, we see that we find I and J. At position I we have E, and at position J we have C, which is a mismatch. Now what we need to do is we need to check the J pointer, and we have to reset J not to 0. Unlike in other algorithms, we need to reset J to 0 and try to find the pattern again. But in this case, the KMP algorithm helps in reducing the number of comparisons by smartly resetting the value of J to previously found pattern where we could start the matching again. Okay, so in this case we found a mismatch at I and J, E and C. There's a mismatch. Now we check the LPS array. When we see the LPS array, we check this particular position. We see D is equal to 0, right? So J is at C. We check the previous one, the previous value of J, and check what we have in the LPS array. Right now it says 0. So in this particular case, J is 0, right? It moves here. And now we start comparing again from J equal to 0, but the value of I doesn't change. Okay, so we check I is E, and now J has become 0, so we check E with A. It's again a mismatch, right? But since J is already at 0, we don't have to do anything. We move pointer to the next, right? That is A. Now we check I, which is pointing to A, J, which is already 0, again pointing to A. This is equal, so we move one step ahead. It matches again. we move again ahead, again here, here and here. In this case we do find a pattern here. So this is the pattern that we have found. So this is how we can use the KMP algorithm to reset the value of j at where we find a mismatch, right? So mismatch, use LPS array to reset j value. In this case it was a pretty easy one because we found the pattern in this next iteration itself. Let's look at another example where we have multiple resets that will happen for the value j. So we have this text and we have this pattern. The part that you see in blue are the indexes where the mismatch happens. So I've done that since the text is long. Okay, I've created the LPS array. Let's see how the LPS array is created. So A, B, C, D all have been appearing for the first time, so everything is 0. But then A, B, C is appearing again, so we have this particular pattern. That's why it's 1, 2, 3, and then Y becomes 0 again. Now let's try to understand. So we have I is here, and j is the first in the pattern. So let me write it here: A, B, C, A, A, B, C, D, A, B, C, and Y. So we have j here, right? We compare A matches, then we compare I the second, then here j it matches. It matches at C as well. Now the next time when we go, I is at 3 and j is at 3, which corresponds to x, and this corresponds to d. Now this is a mismatch. Since this is a mismatch, we check the previous j. So j was at 3, so we check 2, which is j minus 1, which is 2. So we check this particular value which says 0. Now j becomes 0, but we have not changed the value of I is still x. Okay, and j is 0, which corresponds to A. Now we compare I equal to 3 and j equal to 0, which corresponds to A, which is again a mismatch, right? So I is here, which is again a mismatch, but the value is already at 0, so we don't have to do anything, right? We increment I to the next value, which is here. Now we see I is equal to 4, j equal to 0, which is both correspond to A, so there's a match. Then we increment both. I comes here, B matches with B, C matches, D matches, A matches, and again B also matches. But now the mismatch happens at the 10th index. So I equal to 10, j is equal to 0, 1, 2, 3, 4, 5, 6, and j equal to 6. This position we are comparing x again with C, right? Because 6th, that's the index. There's a mismatch. What do we do now? Look at j minus 1, which is this particular part. It says 2. So we need to make sure that the new value of j is 2. Why? Because when we go to 2, understand we are skipping these comparisons of a comma b, because at this particular index there's a mismatch, but we have already compared a comma b, so we already know that a comma b has already been appeared before, so we don't have to start again. We need to start from index 2 and check the third element directly with x, right? So now what we do is we check x, which is at, so I equal to 10, j has become 2. We compare x with c. Which is x, and a becomes c. There's again a mismatch, but j is already at 0, so there's a mismatch with c, and we are here. We put j equal to 0, which is at a. Now we compare x with a. There's a mismatch again, so now we increment I. So I is over here at a. then and j is 0. So we check I equal to 11 and j equal to 0, which is again a. Now we have found it, so we increment both. B also matches, C matches, D, A, B, C. Now in the last element, which is again here at I equal to 18, there's a mismatch. So there's a mismatch. What do? We check j is 0, j comes at the value D, so j is 7, I is 18, right? Since we did A, B, C, D, A, B, C, and there was a mismatch at this, which is D and Y. That's the mismatch that we found, right? What we do now is j minus 1, we check that in the LPS array, which is this particular C and 3, which says we need to go to index 3, which is here, right? D. Now we compare I, which is 18, with j equal to 3. Does that match? Yes, it does match, meaning we don't have to compare A, B, C again. So we are skipping 3 comparisons again. So we don't have to, previously we skipped 2, now we are skipping 3. And D matches with the D at index 3, which is good. Now we move ahead. A also matches, B also matches, and C also matches. Now we have found the pattern, which is at this location. A, B, C, D, A, B. Oh, so we have found a location at this A, B, C, D. So this is how you do. So whenever there's a mismatch, you look at the previous one, go to this index, and compare that particular I with that particular new value of j and start iterating again if it matches. This is how we do the KMP algorithm. It will skip multiple comparisons which have already been computed because we have the LPS array here, which we have created at the start. This is how the algorithm works. I hope you understood it, and let me know if you have any questions in the comments. Thank you.